Hello, everybody, and welcome to Sparing Partners. I am Monica Paolini from Sensophilia, and I'm your host today. My guest today is Dean Bubley from Disruptive Analysis, and he's a fellow independent analyst, a friend, and it's great to have him. And it's going to be a wide-ranging conversation. We don't know where we're going to go because that's the way we always talk to each other, and that's I think the beauty of it. But we do have a topic today that we're going to try to stick to. Which is 6G and private networks. Those are very important topics. And so the question is, do private networks need 6G to succeed, or does 6G need private networks? Now, I'm sure that most of you know Dean, but I'm gonna ask him anyway to introduce himself, and then we'll get into the conversation. So Dean, over to you.
Monica, many thanks for inviting me on. So yes, Dean Bubley. I'm an independent analyst and advisor. My company is called Disruptive Analysis, but I've been doing technology analysis for far too many years. I set up Disruptive Analysis in 2002, and I sort of cover a whole range of different topics, whether it's, well, in the past 4G, 5G, now 6G, Wi-Fi, satellite, but increasingly a lot of stuff on policy and spectrum, as well as bits of cloud and edge compute. And if I'm forced to, I can probably talk about energy and a whole range of stuff from eSIMs to telecom operator business models and a bunch of other stuff as well. But private networks. So just to give a bit of background, I first saw my first small cell for private or local networks in 2001. I was a financial analyst at the time, and one of the stocks I covered had a subsidiary called IP Access, and that subsequently got acquired by Mavenir as their small cell arm a few years ago. But so I've been following private network evolution for 20 plus years, actually. And it's been interesting to see it evolve, and it's still something where I think that people haven't quite got their full head around it. So I'm really looking forward to this conversation.
It's actually interesting because I started Sensophilia 1 year after that, so we're pretty much same age. And I remember on my first project on small cells, we didn't know how to call them. So we spent hours and hours about deciding how should we, from a marketing point of view. I mean, it was clear what they were doing. And now at least we got that sorted out. Although, right now we think about small cells, but when you talk about private networks, mostly small cells, but you don't think of it as small cells anymore. It's kind of interesting how you talk about the same thing in a way, but in a different way.
And I think the interesting thing is that a lot of there's so many different sorts of private networks that some of them don't use small cells. I mean, you could argue that a railway network using GSMR is a private, or at least a dedicated network, and those are essentially macro cells. And the same thing for a utility company or maybe a large mine or oil field. So, right down to one small cell on a private jet. And so you've got these, I don't know, was it 5, 7 orders of magnitude of scale?
Yeah. Well, actually, so I'm going to go even farther because I think that Wi-Fi is a private network. I mean, obviously, it is a private network. So when we think about, well, obviously, if you talk about 5G private networks, that's a special thing, but, a cellular. But when you look at it in terms of connectivity, what we have when you go into a building or in some place is we have public network and a private network that most of the time is Wi-Fi. So to think about the Wi-Fi, there's not much Wi-Fi networks. No, I'm sorry, private networks. That's not true because there's all these kind of networks you talked about,
Yeah.
special plus Wi-Fi.
I mean, in theory, you could take that and say, well, you could include Bluetooth. And frankly, private networks don't even have to be wireless. A LAN with Ethernet is private, or even a USB cable, but that's stretching it a bit too far.
Actually, I just did a podcast with Mark Gilmore about wireless versus wireline, and the distinction between the two is kind of like disappearing because anything. So you tend to have at the very edge it's wireless, like Bluetooth is wireless, but then eventually you're gonna get into wireline, even if it's cellular. So it's just a question of where you cross from wireless to wireline rather than one or the other.
Totally. And if you think about the connection we have between the two of us for this call, we're probably running our respective computers on wireless to our home internet, which may or may not. I'm using a fixed internet connection. I think you are as well. In theory, I could be on a Pacific island with a satellite backhaul. So you may well go from one to the other multiple times during that sort of, and that's without going via Zoom servers, which have their own connections.
Absolutely, absolutely. And so that's when people talk about convergence as something in the future. It's like we already are fully converged. You can't actually escape it. You don't actually know. Most people, and even I don't know sometimes, what kind of connection I'm using.
No,
And it doesn't
no.
matter. As long as it works, it doesn't always work.
Yeah, yeah. I mean, there's if you want to, you could say, if we could optimize for, I don't know, energy use, let's say, as well as performance and latency, but or privacy and security. This is why I always laugh when someone talks about always best connected. It's like, whose definition of best based on which of the 10 or 20 criteria? It's very hard to say what best means to any one person or company or
Or
application.
yeah, personal. Well, actually, I was recently asked, what's the best network in the US, best 5G network? And is there an answer to that? I mean, there might be some answer, but the issue is that how good is it for you for where you are and where, I mean, and that's going to be different for different people.
And this also factors into discussion about private networks because what is theoretically a good network, a national network, may well not work inside a factory with metal walls, or a mine in a middle of the jungle somewhere, or an offshore wind farm, or all sorts of other settings.
Or just a big building
Yeah,
built with
in the
the
basement. Yeah,
latest energy savings, energy efficiency
glass.
codes.
Yeah, glass and concrete and insulation. Yeah, huge difference. Yeah.
Okay, so let's get to talk about 6G and uh, private networks. So tell us what you think about the dependency between the two.
Right. I think that 6G needs private networks more than private networks need 6G. At the moment, a lot of private networks are still perfectly functional and happy on 4G. It depends what you want to do, what the applications are, what spectrum is available. There's certain countries where the only spectrum available for private networks only has 5G radios, so you don't have a choice. Um, there's also what capabilities you need in terms of not just throughput and latency, but do you need some of the fancier features in later versions of 5G, maybe not network slicing, but things like some of the positioning perhaps, or ability to have better performance uplink, network APIs and so on. So I think at the moment we're getting to the point where some private networks need 5G. If I look forward 5 years, 10 years, can I come up with some private networks needing what we think of as 6G, or at least needing to be involved in the discussion around defining 6G performance requirements or non-functional requirements? I think that private networks need to be in the 6G definition room. And I think there's an argument for when 3GPP and other bodies standardize 6G, there need to be people looking at those proposed specifications and interfaces through the eyes of someone deploying private networks, whether that's an enterprise, whether it's a government, whether it's a neutral host, an operator's B2B arm, a military, or whoever. So I think that the private networks need to be in the 6G discussion, but I don't think they need 6G urgently today. There simply aren't the applications there.
Yeah, and I guess that, you can say that about 5G too, like the ultra low latency. Beautiful thing, but really it's something that it's only necessary to a very tiny percentage of private networks because it's expensive to provide. It's
And the
you only
standards
need
are
it sorry?
the standards and the equipment you can't buy. I mean, this is one of the problems with private networks today. I was talking to someone from an industrial background, and they were saying all the stuff we were promised that would be good for private networks and enterprises. Whether it's ultra reliable, low latency, the mythical 1 millisecond support for time synchronized network, you can't buy it. There might be a demand, but there's no supply. Um,
Yeah.
and so I think that the first thing that private networks need is the 5G that they were promised 5 years ago, which they still can't get.
Yeah. Well, I mean, I guess because, we had this kind of idea that all the network would be ultra low latency, which even if you do have a solution, it would be hugely, massively expensive. It's not worth it because people don't need it. Not
I
even
agree.
need the 1 millisecond latency,
The,
you
the, the,
know?
kill, the, ki- the killer app for private 5G at the moment is video uplink, I would say.
Yeah.
And particularly high density video uplink if you've got 10 cameras on a dockside crane or in factories where you need to sort of do quality monitoring. So if you've got really lots of cameras sending real-time high def video in a small area, I think that's a sort of a bit of an obvious win for 5G rather than 4G. But I'd say that's the if you like the killer function at the moment.
And it's not like you need reasonable latency, but you don't need ultra low latency for that.
No.
I mean, that's only for like manufacturing automation, that kind of stuff, which is really important. But again, this is not really the market is very limited.
I would say there's a few things that I mean, the broadcasters would be another group, maybe perimeter security cameras. But again, you're right, latency isn't so much an issue as uplink capacity, maybe reliability and redundancy or support of the number of devices in a given area. But it's more that rather than we need to have our conveyor belt and machinery working at 1 millisecond, well, or even 3 or 5 millisecond, 10 millisecond latencies with regularity. Because there's actually various other non-vendor reasons why that's quite hard to achieve to do with framing and the spectrum policy and so on.
Yeah, and you might have to, it might not be really a kind of 3GPP 6G. I mean, it might be like a very proprietary. I mean, if you have like, full automation of production, it might be that that's the kind of thing that I'm all for disaggregation and all that, but that might be the kind of thing where you have a really absolutely dedicated network. Or something.
And I think possibly a dedicated network with extra features. So one of
Yeah.
the things I heard recently was that for sort of 3G, something like 80% of what was in the standards actually got implemented. And 20% didn't. And for 5G, someone said that essentially the ratio is the opposite way around, where 80% of it is left on the shelf. It's IPR that someone's developed. So they file patents, but they don't have any products to sell. And so I wonder when we get to 6G, maybe we have more of a sort of a model where you have extensions or plugins or you create a framework so that actually the same way we've got a version of 5G for rail called FRMCS, maybe you leave it up to the 5G ACIA, the Alliance for Connected Industries, and to do whatever it is you need for factories, and it's their problem to do it rather than 3GPP. Maybe the broadcasting associations do a broadcast plugin which optimizes for outside broadcast or major events or sports or whatever. And you can imagine that if you have the architecture to do a plugin, same way you do for a browser, you make it more modular, that each of these interest groups could then do their own flavor. And you don't need interoperability between the broadcast version and the mining version. And if someone thinks there's a market to do an extension, good luck to it.
Yeah. No, absolutely, you're right. And then it just gives you the flexibility because 3GPP has its own structure and you can change it. And it's somewhat inflexible and slow, and it has to be that way because to provide interoperability, you can be changing things every now, you have to be more careful. So
Uh,
there is one end where you have to be a little bit more conservative, whether it's too conservative, it's a matter for discussion, but there is a place where standards need to be more carefully worked out. And then there are areas where innovation and change can happen at a different space and pace and for a different market. So I think we shouldn't just think standardization is the one bag and that's it.
no, and I think it's an interesting contrast with Wi-Fi because, well, actually, Wi-Fi is based on IEEE 802.11. And the thing is that a lot of other people who are not the Wi-Fi industry with the certified Wi-Fi brand from Wi-Fi Alliance, people take 802.11 and do other cool stuff with it. There's lots of sort of proprietary or semi-proprietary versions that are used in industrial premises. Is it DSRC that's 802.11p or something like that for vehicle to vehicle. There's special versions that get used in, for fixed wireless access, and I'm sure there's stuff that the military use, and so almost like they've decoupled the basic technology layer from, well, the main version of it commercially is Wi-Fi, but if you or I wanted to go create our own quasi Wi-Fi thing, which we couldn't use the Wi-Fi brand on, or else Wi-Fi lines would shoot us. There's nothing stopping us.
Well, not only that, but before you even get to sort of that extreme, you have a lot of IEEE parts of 802.11 that are completely obscure and archaic that nobody, I mean, not that many people use, but there is still a use
Mm,
because then it's a foundation for people to go on and even the Wi-Fi Alliance programs. There's so many of them, but not
yeah.
everybody uses all of them, and that's by
Well,
design
no.
because
And
not
then you have
everybody.
people who do stuff on top of it. So you've got things like the Wireless Broadband Alliance that does open roaming as a case in point, where
Yeah,
that's on top of Wi-Fi implementations.
yeah. So this is a kind of well, not a problem, but I think that sometimes we tend to think of 3GPP of having to do it all, and it's like, well, they have a very important role, but there is more to it, and we don't want 3GPP to be so constrictive that you cannot that limits. Not that they really
And
can.
And I think that one of the challenges has been that everything in 3GPP is very, very tightly integrated and coupled together. So you need to have the RAN and you need their core, and if you want to do sort of make phone calls, you need IMS, which is specified by the way. And they're all sort of the interfaces are designed to be very heavily integrated together and a system. Whereas a lot of the IT world is you have subsystems with APIs, and if you want to use a partial part of the system, you can. And so I've often wondered whether we often talk about convergence and integration, and you can certainly can drive Wi-Fi from a 3GPP core. Well, why doesn't the opposite apply as well? Why can't you have a Wi-Fi cloud controller with a 3GPP? I call it a naked radio. And I think that wherever you have interoperability, it ought to be bidirectional.
Yeah, actually, that kind of reminds me of the voice over Wi-Fi, which works very well if you just use it with Wi-Fi. But this is like if over the last, I would say, 20 years, we've been trying to do roaming, I mean, handoffs from one to the other, and intrinsically it just doesn't work. And the reason for that is that because with the cellular network, the network tries to have control over the whole thing, and Wi-Fi has it from a device. So there is this kind of fundamental philosophical, in a way, difference. And
Yes.
so you cannot just get the two. So it's much better to keep them separate, I think, at this point. I mean, like if I'm on a call with you over Wi-Fi and I move to cellular, let's just cut the call and start it again. It's easier.
Or you have two separate independent connections
Yeah,
and the operating system bridges
yeah,
between them. Yeah, and it doesn't have to be cellular and Wi-Fi. It could be public cellular and private cellular. It could
same
be
thing.
with satellite. It could be dual SIM for So I went traveling last week and I set up an eSIM on my phone as well as my roaming SIM. And essentially the operating system, the iOS, has some function to work out in any given place which has got coverage, which connection to use. Um, all right, it was probably cost inefficient, but it was an interesting experiment. Um, so I think that type of dual connectivity or multiple connectivity is going to happen not just on private networks, but generally. And that has all sorts of ramifications for all of your things like sort of network slicing and control and policy management, where the end user device or the OS or the, if you like, administrator is the user or perhaps their employer, rather than the operator. And I think this comes back to the fundamental reason why private networks are important in 5G and in future 6G, is I think that the idea of who is the administrator is something that doesn't get explored enough in 5G and its predecessors. And the assumption has always been the administrator is a mobile operator. And for some cases, that's fine. But I think for enterprises, and certainly governments and, let's say, public safety agencies and military and railways and utilities, they want to be their own administrator. And it may well be that the CIO of an enterprise wants to be the administrator, or a building owner again. And particularly, I know we've talked about this and I've talked about it myself for ages, is for indoor or on-site connectivity, there's this fundamental tension between the public mobile operator and the owner of that private space in terms of who has control, but also who spends the money. If you have a metal factory, who spends the money to put the connectivity inside it? And if you're spending the money on radio coverage, whether it's small cells or DAS or whatever, then you want some measure of control over it because it's your network. You paid for it.
Absolutely. Now, this is like an absolutely crucial thing, and I want to continue this, but I want to go back to the 3GPP thing for 1 second, because so you said, like 3GPPs, everything has to be completely correlated and whatever, so core, RAN, and all that. And if you look at it from a private network point of view, it's like, we really need that. But from a public point of view, from a public network point of view, you actually do need, I think, that kind of like more tighter integration, because it's you need to get the network to work nationwide, or then you have roaming and all that. So you have a different set of requirements. But isn't that the reason why 3GPP is kind of ill-equipped, but to deal with this kind of networks? Because if you do try to get the best network you can from a public network, you are not going to be able to, or so far they haven't, been able to provide the kind of flexibility that you need in a private network. And part of that comes from the fact that 3GPP has been created by mobile operators and vendors to serve that ecosystem. So 3GPP is funded on the assumption that it's a public network. And so to get private networks to come in, what do we do? Do we need to get the enterprise to participate more? And what enterprises would want to take the workload to do it?
Yeah.
And enterprises is just so.
And there's so many different sorts of enterprises as well. And so you've got everything, I say, broadcasters to mining companies to airlines to armies to hotels. And for me, this is one of the things I actually got a bit of a debate with someone on LinkedIn this morning about this. Is the encapsulation of all of this is 3GPP's term non-public networks. Which to me is almost like dismissive and derisory. It's like, oh, it's that secondary thing that people have been talking about. And the original definition of these so-called non-public networks, it was almost like had an apologetic version, which is, oh, there's three versions where there's different levels of operator involvement, and there's one version which is, oh, that's purely privately owned. And it was sort of like tacked on the end. And it's that attitude which to me it verges on arrogance and hubris, and the assumption that it's the corner case. It's not our main mission. Of course, everyone would like to use a public network if they could. There's just these rare exceptions, and I think we need to turn that round. And I think the key thing for me in 6G is to make it business model neutral. which again is with Wi-Fi is already there. It can be a public service, it can be a private network, it can be a government network, it can be a shared network, it can be a free network. It can be decentralized. Yeah, there's all sorts of things. And once you start going down that view of thinking, well, it's a network, and there's lots of different people who might want it for different purposes at different scales, different budgets. It's not an identikit 3 or 4 national MNOs, but it's thousands, perhaps even tens of thousands or even millions of networks. Then I think you look at a different framing. You can almost there's a straw man here, which is rather than saying 1 million devices per square kilometer, how about 1,000 networks, independent networks per square kilometer? What would you have to do to make that work?
And I'm completely with you on that, but isn't the inherent problem of 3GPP is also that mobile operators might not be on board with that model because it's going to be challenging their model and not just their technology model, their revenue model. When
It's
they're
not
already
separated.
facing
It's also the big vendor. It's also the big vendors, and there's some geopolitical forces at play here as well, which I think are sort of fairly clear to a lot of people watching this as to or listening to this in terms of what types of company want their own network and which of them are happy to be overseen by government, should we say. And I think there's a bit of an authoritarian versus libertarian divide here, as well as sort of operator versus enterprise.
Yes, but so I'm not quite sure what's the best way, but to expect and hope that 3GPP is going to be all in favor or also supportive enough of private networks, it seems like a bit too optimistic unless they see that there is no other way around, because operators, mobile operators cannot spend the money. They do not have the money to spend to get the indoor coverage that we need. It's just
Yes.
like we know that. They know that. I mean, everybody knows that. And you need to
So
have
I got some numbers on this. So I looked this up, and there's 250 billion square meters of indoor floor space. About 75% of that is residential, and 25% is enterprise and industrial, roughly, give or take. So that and at the moment we don't even know what percentage of that floor space has public 5G coverage, standalone or non-standalone, decent Wi-Fi and fixed broadband. There's no stats, and I think part of the problem here is the industry and also policymakers and regulators don't analyze this. There's no number I've seen of saying this is the amount of industrial floor space in a given country that's got good outdoor to indoor or local provided cellular coverage. And unless you have that data, it's very hard to get policymakers to create good rules or for regulators to create appropriate spectrum policy. And so I think part of this goes back to thinking, well, what's our wish list for the data and statistics? And if the operators won't give it to us, can we use crowdsourcing or AI to estimate it or something else? And actually do data-driven policy and for spectrum and for R&D funding and a whole bunch of other sort of policy levers.
Actually, that was a major issue when there is a question of how much should be unlicensed and therefore Wi-Fi versus licensed, because clearly unlicensed, when you go to indoor situations, unlicensed is most of it. But even there, we have somewhat very scant data on what is it. So all the arguments on both sides are based on what is that people do. I mean, this kind of a very general, high level view, but they do not really look at what is that people currently do and we should expect them to do. It was based on like some kind of very high level assumptions, and all those models are kind of like really
And you'll find a lot of the
that.
testing is to the outside of buildings, and then they'll model what they think is indoor coverage. But actually, you then need to factor in things like over the same time frame as 6G, we are insulating all our buildings. All the new buildings have essentially more effective insulation in the glass or inside the concrete or brickwork. And I actually spent some time looking at building regulations for a while, like all the LEED compliant buildings, and they've got plenty of stuff about how far from a train station you have to be and how many EV chargers you need to put in the car park. There's nothing about you must have fiber up the rises in the buildings and space for antennas or anything else. No one thought to actually put that into the building regulations. So
Mhm.
we're creating or refurbishing a generation of Faraday cages.
Yeah, they have that. Yeah, but I think that it actually is a good thing because
Hmm.
what you do is that you enable spectrum reuse. So it's clearly bad on day one because it's like, okay, the new building has no indoor coverage. But if you know that and you build the indoor infrastructure, then you're fine.
Yeah, the problem then is timing because even in just a country like the UK, there's 30,000 big retail sites, and I don't
Mhm.
know, probably 10,000 hotels, whatever the number worldwide of buildings and structures that could benefit from a dedicated indoor wireless system is probably in the tens of millions, if you include schools and universities and things like that. And there simply aren't the staff or the skills or, frankly, the budget to put dedicated indoor coverage for public networks in more than a tiny fraction of that. Because it might cost anything from $1 to $100 per square meter. And so if it's $100 per square meter and there's 250 billion square meters, that's like roughly planetary GDP to sort of rewire or put indoor coverage everywhere, which is clearly not going to happen. Yeah, and not to mention the fact that there's probably only, I don't know, 100,000 engineers globally who can do it. And so it's like the risk is that if you're a mid-sized hotel in a mid-sized city, someone and you say, oh, I want to have an indoor system. It's like, well, please take a number. Oh, your number 3,482. We'll get back to you in the year 2037. Yeah, so there needs to be a short-term solution, which is probably Wi-Fi.
Yeah, well, Wi-Fi, it's not a short, I mean, like it's already there. But
Yeah.
I remember a few years ago, I was talking to somebody that like a real estate developer. So we were talking about, they were building whatever thing new, with all the new codes and whatever. And I was surprised because he compared the cost of indoor connectivity to the cost of carpeting because it's just like you build a building, you do it. So clearly, it's kind of hard to think backwards of what we already have.
Yeah.
But if you're building something new right now, you build it in, so you have all your kind of super efficient whatever, and
Yeah.
the cost is actually not that much compared. I mean, it was actually
Uh,
cheaper than
oh,
than
and
carpeting.
also you capitalize it in the building construction costs as well. And so you've got a different depreciation schedule, at least for the things like the passive components, like the trays and the risers and maybe the fiber. And the active stuff obviously has got a different depreciation schedule. But financially, all this stuff would make an awful lot more sense if it's built into the building fabric costs. And in some parts of the world, it is. My understanding is in parts of the Middle East, it's built into more the building codes or the regulatory. I know when I was talking to someone about Ireland, they're talking about multi-operator indoor coverage for new apartment blocks and things like this. But it's very patchy, and I try to look at the sort of the rules on are there regulatory policies, regulations or policies specifically about linking spectrum or mobile networks to indoor coverage. And there's bits and pieces, but it's very different around the world.
Yeah, but that sort of brings all the issue about spectrum availability. Because let's say I'm this guy that is building a new building. And it's like I want to put, I mean, I'm going to put Wi-Fi, obviously, and I want to put small cells. But in order for me to protect my investment, I need to have access to spectrum that does not require me to have a lease, like a neutral host lease with every operator, because I need to be in control of the network. I put the money, I need to control it. So you need to have a spectrum allocation that is, so in a way, I would say that maybe that part is more important than 3GPP getting its act together on private networks because you need to enable the enterprise.
Yeah, and it's not just spectrum. I mean, it's probably if governments say, "Oh, you get tax relief on putting indoor wireless infrastructure," or there's a bunch of stuff, or you need to report whether you've got good coverage, or the government goes out and measures it, whatever it is. There's a bunch of policy which is outside of spectrum, I said we should go as far as tax and building codes and all this stuff, which you and I probably don't spend much time thinking about.
Yeah, actually, there is another one which is for energy efficiency.
Yep.
So okay, I'm still building this network, and my connectivity power goes into computing the overall power thing. But if you look at it from a macro point of view, my indoor network is going to be much more energy efficient than using macro to connect. So if I'm
Yes.
inside the building, it's much more efficient to connect to the local
Yeah.
network than. So we should also rethink that.
And
That,
so maybe,
yeah,
yeah,
sorry.
but maybe the way to frame it then is whether it's 6G, these private networks, or whether it's the 6G era, which includes a bunch of other technologies. So 6G era is basically the 2030s. We need private and on-site networks and indoor networks. And I think that there will be some of those networks that need specifically whatever 3GPP or anyone else comes out with for 6G, if they've got, super duper robots or whatever in a factory with a high density of cameras and sensors and all the rest of it. But actually, I think it's the 6G era needs the to think through the from the angle of private and indoor connectivity, whether it's for residential space like apartment blocks or commercial property like a retail store or industrial like a factory or a warehouse. And I think that once you start looking through that lens, then a bunch of this other stuff falls out of it.
Yeah, absolutely. Like for instance, SIM management or the idea of a phone number as making you part of the network is outdated. In that kind of world where you have a lot of IoT devices, and what do you need a SIM card? Authentic.
Well, exactly. I mean, then it comes down to who's administering it and what else do they use. So if you've got an enterprise and you've got your existing enterprise security tokens and you're using whatever the protocols you've got, you may well find that you want to add your private cellular devices on to your existing security and authentication platform, and it might use SIM, it might not use SIM. It's there have been a couple of attempts at doing sort of SIM optional in the past, but I think that there it very much comes down to the CIO or the building owner or perhaps an integrator or neutral hosted depending on the situation. And it's their security, their authentication mechanisms. And if essentially if you've got a warehouse with 1,000 devices connected to Wi-Fi or fixed Ethernet, and you bring in 10 AGVs, you're not going to sort of change the 1,000 over. You're basically the 10. The new stuff has to work on the old system. If you're building a gigafactory from scratch, you could make the whole thing, if you like, 5G native or 6G native on day one, and you just say we're not going to buy anything, even a screwdriver that doesn't come with a 6G radio in it. Good luck, and it's going to cost you lots of money, but you can do that if it's greenfield. Brownfield, not really.
But even for a greenfield, would you do that when you know that the ecosystem out there for Wi-Fi devices is so much wider?
Uh,
Uh, you know,
It might be. It may be you've got other constraints that you've standardized on a particular security model that works better on cellular, or you want to have something where you don't need to have the density of access points that you get. The one advantage is that the cellular can run at higher powers. Now, you could make the argument that maybe we should have higher power Wi-Fi inside metal factories. So you change the power limits, so you don't need as many access points per square meter or cubic meter or whatever it is. But I think there will be some settings where people will try to be all cellular, and there will some where they try to be all Wi-Fi, and many in the middle which will have a mix of both. Particularly
which yeah,
if you've got people coming on site. And so what one of the things I think that's interesting, and talking about cellular, is you have things like military is increasingly going towards using cellular, probably with some of their own security tweaks. But if you imagine organizations like NATO, where you might have a coalition force of people of organizations, people and machinery and vehicles from 10 different countries, then it makes sense to have something that's standardized and is perhaps more agile in terms of frequency options. But yeah, it's going to vary.
Yeah. Well, and I think that, an important thing is to actually get the Wi-Fi and cellular and whatever other technology you have to be kind of managed in a sort of a mixed, to have the same kind of management. And it's kind of basically IT based rather than, it's a different mindset, not
Yeah.
just a technology, it's a mindset. Who is going to be responsible within the organization? And that's
And,
where I think that in a private network, yes, you can have a mobile operator operating it, but when you get into this kind of very specific complexity, multiple networks, then you do need the enterprise to be really in charge of it.
one challenge here is where you have multiple organizations or enterprises on the same site and how they interoperate. So you could think of an airport which has got maintenance companies in the hangars, the airlines, the fuel companies. Some of those, the hotel outside the perimeter fence, that they may well all have their own networks. Or on a construction site where you have rental equipment which is connected, and you've got contractors coming on site with a cement truck. And that gets a little bit more difficult about how you onboard the visitors or the third party tenants or the co-tenants on one site. And there you might need to have cross network coordination and possibly cross technology coordination as well. So, if you're an automotive factory and the robot you buy comes with its own Wi-Fi or its own private 5G built in, how do you deal with it when you got? I talked to CIO, I think it was Aston Martin a few years ago at an event, and he said every time we buy a new robot system, it comes with its own Wi-Fi, and we've got 10 different networks in the factory. And obviously,
Yeah.
they don't coordinate. You end up with interference. And I can imagine that being the same case where you've got private networks where maybe they're using different spectrum bands. Does the owner of the site get to define how all the tenants use their wireless? That gets really complicated for an airport or a shopping mall or a sort of even a smart city. You can't necessarily have one landlord telling everyone else what wireless they can and can't use.
Well, yes and no, because if you're an airport and you have full control over the space, I can see, airports
Hmm.
are kind of,
Airport's a
especially
special
like you
case,
see
yeah.
in the US with CBRS, they say, okay, we have we control the real estate. So you as, whatever user you are, you're going to be using my network. It's going to be a virtual network. So you can do whatever security or whatever, but I own the infrastructure, and you just in some cases, like the rental agreements are such that you can now just put telecom infrastructure. You cannot even put Wi-Fi. If you remember, there were some cases where
Hmm.
you can, you're a retail store in an airport and you cannot put your own Wi-Fi. That is
Yeah.
kind of a little bit difficult because it's like public, and you can just go as Dean and just
You put
have
the
your own.
hotspot function on your phone, you've got your own Wi-Fi network.
Yeah. So it's not that trivial, but there is a sense in which it might
Hmm.
make sense for the airport because you control the real estate, and therefore the network is part of the real estate.
Yes,
So you can just
I would say yeah, but then you've got the hotel outside the perimeter fence, and you've got the railway. Yeah, you go somewhere like a big airport, like oh, is it Indianapolis, where you've got half the airport is FedEx or UPS terminal or something like that. Yeah, you're probably going to find that, or you've got the military airport next to the civilian airport, or there's a lot of hundred corner cases here.
yeah, no, right. It's not that simple, but there is a sense in which you control the real estate. And the problem is that in a lot of places you might have different people controlling the real estate. So like
Yeah.
you have different floors in the building. You can't just
And
say,
so yeah, and exactly, and I think there's one of the things I've been talking about recently is evolution of things like spectrum sensing, maybe even spectrum digital twins, because you don't necessarily know what's there. And for some sites, like say a military base, you absolutely need to know, are there any unauthorized transmitters? is clearly an issue. But it
Well,
could,
and
but
also,
even for industrial espionage, you want to know is someone put a bug in the, and there's still, it wasn't just like 1960s spy movies. People still do industrial espionage, and you can now do all sorts of weird frequencies. You can mask your signal in something else. And so you've got to have much more situational awareness around what networks exist, whose are there, who are they authorized, are they anomalies, and I think there's going to be a lot of development there.
well, and also because whatever situation you have today is not going to be the same year from now. I
Yeah,
mean, like you see that with CBRS, for instance, where you have on day one, you might have very limited, and then eventually it will grow. How can you can now by definition predict it? I mean, you can sort of have some educated guess based on who is around, but the tenants on the floor above can change. What do you do about it? So
yeah, totally,
anyway.
totally.
I think that we need to stop here because otherwise we go on forever. But it was great talking to you. Maybe we'll have another one talking about well, we'll see what's going to happen. So, well, thank you so much for sharing your thoughts with us today.
Monica, thank you so very much as well. It's been a really, really enjoyable conversation. If people want to follow me on LinkedIn, I write regular posts and also have a newsletter there, and I'm still using X, and I've started using Blue Sky as well as Disruptive Dean. But otherwise, I'll hopefully be coming to a live conference near you as well sometime.
Absolutely, and I will put the link in the description so that you'll be able to read all the stuff from Dean, and he's very prolific. I don't know, Dean, how you find the time. I'm very envious of you.
Thank you. Cheers. And I'm very envious of you doing the podcast and video. I've been meaning to do it for ages and I haven't got around to it. So anyway, thank you once again.
Thank you so much, and thank you all for listening in. And if you like it, do subscribe to the podcast feed on your favorite podcast platform. Thank you so much.